Can you grab a coffee?
Yeah,
You
of
can
course.
get inside, right? No,
Yes. And how about you, Katerina? I remember you. No, I was just talking
Okay,
to
okay.
a participant here in Zoom. Welcome back, by the way. Remind me, you said you come from a non-tech background, but what industry in particular? I'm just trying to see where everyone's coming from. If you're there, maybe if you can drop in, let me know in the chat. What industry? What is your background? And how about you, sir? We were just asking. We will begin in 3 minutes. And yeah, 3 minutes. We're just asking everyone what is their background. Are you a tech person, non-tech person?
I'm a tech person.
Tech person?
Yeah.
Could you be more specific?
So I do some cybersecurity consultation.
Okay. Very interesting. We started our topic about cybersecurity threats. Our friend here has to deal with that every day, or his job is to prevent his company's infrastructure from being compromised. Our friend here is in the business of producing drones for military purposes, and you, of course, cyber warfare. So what does that look like, by the way? Is it something you always have to adapt on a daily basis, monthly basis?
Things are always changing.
And who are the biggest threats? Private organizations, state actors.
It's not really about who's the biggest threat. It's more about just keeping yourself protected from whoever it might be, because that's always changing as well.
Okay. Very interesting.
It could be, some random person and some kid in his house playing around on the internet, and it could be spies from another country. So you got to be ready, regardless of who it's going to be.
So does your system or the company at which you work implement AI to some extent or another yet? Or is it something you're considering, or you're considering?
Something we want to get into. Yeah.
Something you want to get into. Very good. Hopefully you will find today's session useful.
I'm so looking forward to it.
Okay, one more minute and we'll begin. Well, let me tell you about the agenda for today. This is episode 2 of the data series. There are 4 episodes. The first one was very broad. We talked about some, we wanted to have clarity about some buzzwords: data science, big data, machine learning. These words are thrown around a lot, and it's not quite clear what they really mean. Today, we're going to quickly go over data science, just so we have some context, and then we can get into machine learning, the central component of data science. Okay, in fact, we'll begin now. And of course, there are different categories, or there are different ways you can use machine learning. We'll look at those, and then if anyone has any questions, I'm here to answer them for you. So let's go over data science. Again, we said that data science is an emerging field, and it's where 3 disciplines meet each other. Okay, statistics and mathematics, computer programming, and domain knowledge can stand for any type of domain. So it could be sales, it could be manufacturing, it could be healthcare, etc. Okay, data science sits at the intersection of these 3. These are the 3 pillars of data science. So a data scientist is someone who has considerable statistical literacy, but also has or requires some amount of computer programming knowledge in order to translate those statistical techniques into programming, or automate them and apply them to large volumes of data with programming. So applying statistics with the power of computing. But a data scientist must also practice their skill to solve problems in a specific domain. So you're a data scientist in logistics, you're a data scientist in sales, you're a data scientist in banking. So a data scientist is expected to meet these three requirements. Okay, but primarily, Allah will come, primarily statistics and mathematics. Now, in the first episode, we went into the different branches of mathematics. So when we say mathematics is quite broad. Some mathematical disciplines are more important than others, like probability theory, for example, is at the heart of it. But to plug in or to have context for the terms machine learning and big data, we have this diagram. So we said that another word for machine learning is statistical learning, because everything in machine learning, every concept that you come across in machine learning is directly from statistics and probability theory or is inspired. So ideas are borrowed from statistics and probability theory. Big data has to do with this phenomena of so basically we have, when we talk about data, we mean data that lives in the internet, so to speak. And there are four things that describe, there are four things that define big data. The variety of data, so that we have these things called the 4 V's. So the first V is for the variety of data. We have all kinds of data, text data, pictorial data, and they come in all types of file formats: TXT, CSV, JSV, JSON, JPEG, PNG, etc. That's the first V. The second V is the volume, the sheer volume of data. Every day, we have hundreds of gigabytes, petabytes of data being generated. And the velocity. Not only do we have large volumes of data, but the rate at which it's being produced is incredible. Every second, people are posting things, taking pictures, sharing them. And the fourth V is the veracity of data. So even though we have a lot of data that is being generated rapidly, we have a mix of useless, false, redundant data and valuable, relevant, accurate data. So a data scientist must be able to handle the 4 V's of digital data. They must know enough. They must know the technologies that manage large volumes of data that are produced at high velocity. But in particular, they must use their knowledge of statistics to distinguish between data that is valid, correct, and data that is junk, garbage. There's a saying in machine learning: garbage in, garbage out. If you have the best machine learning model, and we'll talk about what a model really is, if you have the best machine learning but you feed it garbage data, the results will be garbage. So for a data scientist or a company that will be adopting machine learning, their most important asset is data. So for a data scientist, for example, will spend the bulk of their time validating the data, not so much creating machine learning models. Okay, so the time it takes to prepare the data is quite substantial, and it takes the bulk of what we call the 5 stages of the data science process. Which are these? Okay, now we will revisit this in a moment, but so this is the 5 stages of the data science process, correct? This is what a data scientist must do. This is what a team that is working with data and machine learning, this is what you must do before you can get into machine learning. First, you have to have the goal, establish the goal. What problem are you trying to solve with data and machine learning? Then you must go about acquiring the data, and this can come from different sources. But then before you can start machine learning, you have to deal with the correctness. Remember, we said that data, we don't want to have junk for machine learning. The data has to be useful. And then we can get to machine learning. And after machine learning, the results of the machine learning, you can make decisions that are driven by data. Okay, so you're not going by your, what's the word? You're not going by instinct. Rather, you're going by facts, or at least that's the idea. So today we want to get into machine learning. What is this thing? What is this thing? How does it work? And what would you need to know to practice or employ machine learning? Now, what they say, when people refer to AI capabilities, what they really are referring to is machine learning. If you remember in episode 1, we talked about the 3 types of, or 3, not 3 types, but 3 tiers of artificial intelligence. We had narrow artificial intelligence, which can do something very specific. Okay, so if we compare AI capabilities to human capabilities, narrow AI can do something very specific. Like if a human can do very specific tasks, like uh, classifying an image. This is a cat. This is a cat. This is a dog. Narrow AI can do that as well. But then the third tiers were uh, generalized artificial intelligence, where the AI capability is equal to that of a human being. Okay, and the third tier was super AI, where the whatever the AI thing is, whatever that algorithm is, it far surpasses the intelligence of any human being. So what we're looking at, all of these are examples of narrow artificial intelligence, okay? Which we would really call machine learning, because if you want to, if all of this AI applications are really applications of machine learning, so we'll call them machine learning. Things like speech recognition, where you have an audio file and you can translate it to a transcript, or when you have a JPEG image and you can identify the contents of the face, right? Or you have writings on a piece of paper or on a piece of wall, you can identify the characters, or even autonomous vehicles, right? If you want a vehicle to avoid obstacles and make turns at the right place at the right time, again, that's something that's within the scope of machine learning. Now there are three types of machine learning. We saw these in episode 1, but we will go a little deeper into these. There's supervised learning, unsupervised, and reinforcement learning. Why are they called supervised and unsupervised? Well, I'll bring it to a slide and you'll see why that is the case. Reinforcement learning is quite different from these two. So unsupervised, okay, so let me put it this way. Supervised learning is the closest thing to statistics and probability theory, okay? Almost entirely everything in supervised learning is from statistics and probability theory. Essentially, you've automating classical statistical techniques. Unsupervised learning it's inspired, so it's taking it to the next level. Reinforcement learning, however, is primarily probability theory, less statistics, more probability theory. In fact, a subtopic of probability theory we call dynamic programming. We'll come back to this later on. Now, reinforcement learning is quite mathematical in nature, so we won't talk about this one a lot. However, understanding supervised learning and unsupervised learning can create that foundation for you to learn reinforcement learning. Yes, question?
I can ask now, or should I ask later?
You can ask now, but towards the end we'll have a Q&A. Yes.
Yeah, connecting to this, the supervised learning is primarily the data which you feed into the machine, and then it takes action based on the data which already we have fed into that. Am I right?
Well, what you described applies to all three. Well, by the way, one thing I will do today, which we did not do in our last session, is I have this mapping application where I'm going to map all of these concepts into a tree, so you know how everything we talk about are related to each other. This will hopefully be helpful.
Right.
But I'll come to your question. Hopefully, I'll answer your question within these slides. So, three types of machine learning, and of course, all three of them will take your data. When we say data, we mean digital data. And you choose one or the other depending on what you're trying to achieve. With supervised learning, the output, the expectation is prediction. You're trying to predict some sort of numerical quantity. And I'll give you examples of that. Alternatively, it could be to classify something, to be able to distinguish one thing from the other. Unsupervised learning is for pattern recognition. Okay, so if you're sometimes when you're looking at data, and really in this day and age, we're almost always dealing with large volumes of data. There will exist patterns that are not obvious to the human being, even if that person is a trained statistician, or for that matter, if you have a team of statisticians, they may not be able to identify all of the patterns in this data. Unsupervised learning is able to find what we call clusters of data, certain characteristics that distinguish one type of group from other types of groups in your data. Think, for example, different variants of the COVID virus. Okay, if there are 3 or 4 variations of it, and it's not something that the statistician can do, this is where unsupervised learning can come into the picture. Again, this is just, I'm giving you a general definition. We can be more specific in the subsequent slides. Reinforceable learning is quite distinct from the others. Reinforceable learning is about training a model to make correct decisions. Okay, if we go back to the example with the autonomous vehicle, what are correct decisions for a vehicle? To drive at the right speed, to accelerate at the correct rate, to stop at the red light, avoid running over a cat. So reinforceable learning is about teaching this model, okay, and we will talk about what teaching really means and what it takes to teach a model, but it's about teaching a model to take correct actions, okay? And it's called reinforcement because we reinforce this model by rewards. If it takes a right action, we reward it. If it takes a wrong action, we will penalize it. So we will, if, for example, in the case of autonomous driving, the model is really software, it's an algorithm, and the environment in which it is learning is also a simulation, like a 3-dimensional city, a 3-dimensional street. Okay, and we can observe its behavior. If it drives poorly, we penalize it, and it learns to avoid those mistakes. And if we reward it, it will learn to take more of those actions. Now, these techniques have names. The way that supervised learning works, at the heart of supervised learning, is regression and classification. So supervised learning, there are 2 things you can do with supervised learning: regression, classification. Again, these 2 terms are from statistics. We'll see what they mean in a second. Then we have a special type of classification called clustering. So classification can classify a data point or an observation into one of 2 classes. It's either black or white. It's an apple or an orange. It's a yes or no. Whereas clustering can identify multiple classes. So we'll create a series of classes. So for example, this is an SUV, this is a truck, this is a train, this is a bicycle. What kind of bicycle? Is it a big bicycle, small bicycle? Or how about people? This is a man, this is a child. So with clustering, we can find more classes that are otherwise not obvious to a human being, or like I said, a group of human beings, even if they are trained statisticians. Reinforcement learning, like I said, uses a branch of probability theory called dynamic programming. If anyone has heard of Markov processes, Markov chains, all of that has to do with dynamic programming. Okay, and this technique is everything that we see here: regression, classification, clustering, these things have been around for a while. The most recent of them would be dynamic programming, which was invented like in the 50s by a mathematician. So if you look at in the timeline of mathematics, 1950s is quite recent, but when it comes to computer science, this is quite old. Okay, so if you have techniques that go back to the 50s, it's not really innovation. The innovation, what's really, and machine learning, by the way, was hypothesized many years ago, like all the way to the 60s and 70s. What makes machine learning now a big topic was the internet. Okay, if you go before the 90s, when the internet had not taken off, machine learning was an interesting topic, but it was not really useful. And then come the mid-90s, the internet, everyone has devices. Apple commoditizes the personal computer. Everyone is generating data. And now statisticians or any institution that wants to make sense of data needs something more elaborate than classical statistics. Enter data science, where statistics and the power of computation join forces, and we get machine learning. Let's talk about regression and classification, and then move on to clustering. Understanding supervised learning, or getting into supervised learning, is a great way for us to learn about the technicalities of machine learning. So if we understand supervised learning, we will have the foundation to then understand unsupervised learning, And then from there, we can go to reinforcement learning. And then from there, we can go into something called deep learning. And deep learning, by the way, is something that spans all three of these applications. Why is that the case? We'll see very, very soon. Regression and classification, two things you can do with supervised learning. Does anyone recognize what these are? These are what we call scatter plots. Very quickly, these red dots are what we call observations. So for example, let's say you have a CSV for properties. Properties in Dubai. Let's say residential apartments. So each red dot can represent a particular residential building. Its size in square feet, the number of floors, the number of 1 bedroom, 2 bedroom, 3 bedroom apartments, its location in Dubai, like is it in uptown Dubai, downtown Dubai, parking floors. So all of these red dots are what we call an observation. This is, again, another term in statistics. Okay. So what regression can do is, let's say the x-axis represents your observations, the y-axis, the value of that property. So if you take a property that is, let's say, somewhere in downtown Dubai, and it's the flats are quite spacious. It's a high-rise building, so you have a great view. What does that mean for its what does that mean for its value? Is it going to be an expensive apartment? Is it going to be an expensive property? Or no? Well, if it's in the pristine part of the city, it's going to be expensive. So it will be somewhere up here. Okay? But you see, in order for us to establish the value of a property, we have to know what defines its value. What is it that makes this building more expensive than another building? If we take this same physical building in which we are right now and put it all the way to Ajman, its value will depreciate drastically. But what is it about its price? Is it the location? Is it its proximity to parkings and amenities, to schools? So we take all of these into consideration. We call these considerations in machine learning the features. All of these things that affect the price of the property, we call the features. Now, this black line in statistics represents the model. A model is an equation that represents some real-world phenomena. I'll show you a picture. I'll show you a simple equation in a second, but just keep that in mind. This black line represents the model. If we were to pick any, now, we have some observations in here, right? But we don't have, we're not observing all of the properties in Dubai. Moreover, there are some, if you're a property developer, you may want to construct a building, but you do not know what its value will be. And you want to approximate. What is the best type of building we can create that will give us the highest return? If we make it too big, the cost might be too high for maintenance. If we make it too small, we might not be able to house enough habitats. If we make it too far from the city, not enough people will come here. If you put it in the best part of Dubai, again, that will be expensive for us, or no one can pay for it. So you want the right combination to get the best return for your investment. Regression can do it for you. Regression will learn the different characteristics of buildings in Dubai, properties in Dubai, and then to fit the model means to find if you're able to put a black line, this black line, right through the scatter plot, that means you know very well what is causing the property price to increase or not. This is what we call fitting the model. Okay, so bear with me. I know we're kind of getting to statistics, but I'm just trying to give you some insight. Okay, so for example, if you don't have an example, you can choose any point on this black line, and you can get an approximation for how much it would be worth. And you can, of course, measure how off the mark you are. Okay, classification also uses the scatter plot, except the point here is to draw a black line through the scatter plot and divide your data set into two classes. Okay, let's say you're trying to classify people by their status, their COVID status. Are they COVID positive? Are they COVID negative? Okay, what defines someone as being COVID positive? Is it the symptoms? Is it the number of antibodies in their blood? I'm not a biologist, but what is it that makes a person sick or not? What makes someone infectious or not? What makes someone a potential carrier of the disease or not? Okay, or how about another example? You were talking about drones, right? Classifying a target, a valid target from a non-target. Or if we talk about autonomous vehicles, what is an obstacle, what is not an obstacle? Okay, a car it will move. It's not fixed in its place, but a tree is fixed in its place. So classification can identify what is it that causes something to be it belong to this class or that class. And a simple example would be fruits. What distinguishes an apple from an orange? So oranges are quite roundish, right? And they're all orange. If they're not orange, you probably don't want to eat them. Whereas apples can come in different colors. All colors except orange. I've never seen an orange table. They come in red, yellow, green, right? And they're not circular. They're not roundish. They have the apple shape. So we can use classification. We can train the model to distinguish between an orange and apple. Another example would be tumors. Okay, so whether it's a tumor on a skin or an internal organ, in many cases, you have physicians who incorrectly diagnose or they misdiagnose, like let's say a pigment or something on the skin. They say it's benign, and it turns out no, it's not benign. It's tumor. So we can train a machine learning model to distinguish one class from the other. Yeah, I meant to show you this picture when I was talking about the real estate, but I think you get the idea. So if you want to predict the future price of a product, okay, within reasonable accuracy, you can do it with a regression. Now, how do we train a model? Assuming your data is sufficient, you need sufficient amount of data, and your data has been cleaned, you don't have any fake data and you don't have any false data, you must go through 3 stages before you can do machine learning. There is training, validation, and test. Training, validation, and test. To give you context, to explain really how this works, I need to show you this equation. Okay? I'll keep it quite simple. Remember that regression line we talked about, this black line? And I said that this black line represents your model. This equation represents that line. This is the model. Let me give you an example of how it works. We have these 2 coefficients, b sub 1 and b sub 0, b sub 1. Okay? B sub 0 will tell you what is the baseline. Baseline means at what point does this black line start to cut through the scatter plot. What is that? Why is that important? Let's say you want to predict prices of properties. You must know what is the lowest possible amount, what is the lowest possible value of a property. Even if you produce a building that is poorly built, doesn't have piping, and it's in the worst part of the country, its value will not be 0. Okay, it will be, it won't be valuable, but it won't be 0. Okay, a better example would be if you take any apartment in Dubai, any building in Dubai, what is the lowest amount you can pay for a flat? It won't be 0. Maybe 1,000. There will be a baseline. There will be a minimum. So that B sub 1 represents your B sub 0, the baseline. Now, what we want to know is what causes the price of the price of a property to go up or to go down, the steepness. Okay, that is what B sub 1 represents. Now, this is a very small model. It's quite useless, but ideally, our model would be taking into account every facet of the property. Its location in the country, that would be B sub 1. The number of floors that it has, B sub 2. The number of amenities like pool and gym and helipad even, that will be B sub 3. Let's say proximity to schools, that will be B sub 4.
Services like hospital, supermarket.
Exactly, yeah. Proximity to hospitals, B sub 5. The real estate companies, some real estate companies make sure the building is always managed, maintained, no one's unhappy, so that would be B sub 5. on and on and on and on. So all of these are the parameters that will determine whether the price of a building goes up or down. However, not all parameters are of equal weight. Some things cause the building to be more expensive than others. So for example, the color of the building, who cares, right? It's the interior that's important. This X sub 1 represents the weight of the parameter. Which parameter is more significant? Okay? Statisticians would figure this out manually. Right? They will sit down on a piece of paper and start to solve this equation. Solve for X. Okay? However, when we want to know as much, if we look at the data we have today, so about people, for example, let's say you're trying to predict if someone is going to be diabetic or not. How many things are there to consider? There is their weight, there is their age, there is their blood sugar, their BMI, pedigree. That means if you have any ancestors, if any of your, if any of your ancestors were diabetes, the temperature of your body, and there can be many, many things that maybe a single physician could not take into account. So all of these are parameters. Now, there are some things that would make you more susceptible to diabetes than others. Okay, the color of your hair is insignificant. So what would its weight be in your opinion? 0, nothing. It has no significance. But your weight is okay, especially once your weight starts to climb a certain threshold. Now you're going to be susceptible to diabetes. Again, your blood sugar. What if you're if you are insulin resistance? So the model is going to learn automatically. It's going to experiment to find out which parameter is more significant than the others. So let me come back here. Here's how it works. Here's how we train the model to identify those parameters and the weights of those parameters, like the significance. We start with the training data set. The training data set is just a plain CSV or TSV file. And if we use diabetes as an example, every row in that file is a patient and all of their features, blood sugar, weight, age, etc. Then we have this one column we call the label in machine learning. The label just says, is this person diabetic or not? We will present this training data set to the model. We will say, model, learn. Try to figure out what is it that makes this person diabetic, what makes that person not diabetic. What is that thing that separates them? Okay? The validation data set is where we allow the model, we present additional data it has not seen before so it can adjust its weight. So it will have a first run, and then it will attempt to make a prediction. Okay? The validation data set will allow it to validate whether its predictions were wrong or right. If it was wrong, that means I need to adjust my parameters. Maybe this weight is not as important. Maybe this has to be more weighty. And once we have the validation data set, we have a ready model. This model is now ready for actual data, for real world data. That's what we call the test data set. Okay? The test data set is how you are able to test the accuracy of the model. If it does a good job, you can tell. So for example, by the way, we don't say if it's a good or bad model. We have a range from 0 to 100%. So if it's 70% accuracy, you have to decide, is 70% enough? Is it good enough or not? Okay. If you're going to be predicting price of property, maybe 70% is not so bad. Okay. Within 10,000, 20,000 dirhams. Okay. But if you're going to be predicting, if you're going to be diagnosing someone, 70% might be, it's too risky. Maybe you need a higher threshold. Now, if the test data set will tell us how well this model will perform. If we're not happy with how the model performs, we can do two things. We can try a different machine learning model, or we need to go back and do something with our data. Let's for example, get more data. And if you're happy, you can proceed. You can use it in the real world. So for example, when you're on Amazon and you're looking for products, sometimes Amazon will say, people who bought this also bought that. Okay? Yes?
What's the difference between validation and test here? Both seem almost same.
Not quite. The validation is what allows the model to fix itself. I'll give you an analogy. I will give you an analogy that helps, and I will use boxing. Okay? So let's say you're a boxing coach, and someone walks in the gym and says, I want to be a boxer, and you as a coach want to make this a champion, right? If you have a champion in your team, well, you're going to be a successful coach. So you must first have this athlete, this to be boxing champion, train. So you have this person come to the gym every day, punch them, go at the punch bag, spar with the partner, do some weightlifting, okay? And you want this person to participate in a championship fight. However, you can't just go from the gym directly to the championship fight. You need to have a
Mid-level testing.
yeah, like a little competition, right? So you can have one athlete and another athlete, they pitch them together, and you can watch how this athlete is doing. If the athlete, misses all the time and ends up with bruises on their face, they need more training. Okay? But every time they train, every time they get punched, they learn, oh, I should avoid this person. I should create a distance. Okay? A validation, when you put them into a boxing ring and they get beaten up, they learn from their mistakes. Okay? They learn, I need to be faster, I need to train harder, etc. So you as a coach determine that this person has learned enough for the championship fight. This person has learned enough. They're now qualified to go into the ring with thousands of, what do we call them? Viewers, and fight this professional fighter. However, whether or not this person is going to be a champion or not, will be determined in the actual championship fight. It's the actual fight that will determine whether this person is a champion or not. That's what we call the test data set. Okay? If they win, then you have a champion. If they failed, at least you can go back to the video and see what is it that caused them to fail. Either we can bring it, the coach can go after a new athlete, or no, we can go back and start from over. Okay, maybe give them a new diet, maybe bring in Conor McGregor, whatever. One of those kind of, a few people know Conor McGregor. Who the F is that, right? Maybe somebody will get the reference. Anyway, so yes, the idea is for the model to find these parameters, and especially the weights of these parameters. Now, I didn't tell you about epsilon. Epsilon is the error rate. Okay, epsilon, if I go back to this black line, you see only a few of these observations are actually on this black line. There's 1, 2, maybe 3. Okay, all of the other observations are either above or below the black line. Okay, that distance. The distance from the black line is what we call epsilon. That's the error rate. This will tell you.
So the lower the better.
Yes, the lower epsilon. That means
Close to
the black line.
Does it mean overfitting also?
Overfitting, yes. If it's 0, it is possible for a model to actually follow. I need to show it to you pictorially. But if a bad model will also try to wrap around all of these red observations. Let me quickly show you a picture. Take a side note. Overfitting. This is overfitting. So rather than trying to find a pattern, it is just following all of these black observations. You know what this is like? This is like a student who memorizes all the questions before the exam, as opposed to having intuition. So when they go to the exam, they get perfect score, but that's because they memorize all the questions. If you slightly change the exam questions, since they've never seen the questions before, they will fail. So we don't want the model to, memorize the parameters. Just find some pattern. Find the weights. Now again, this is quite technical detail, so I don't want to go too off tangent. But yes, there's a way you can measure overfitting. Okay. My point was with this little slide to demonstrate that everything in machine learning is going to come from statistics. To become a competent machine learning practitioner, or to interpret the results of a machine learning model, is to be able to. You need to understand those statistical terms. Okay. Unsupervised learning. Now, unsupervised learning, there's only one thing you're doing with unsupervised learning, and that's clustering. So classification is going to divide your data into two sections. It's either apples or oranges, whereas clustering goes beyond that. You're looking for multiple patterns that you're unable to identify on your own. Like I said, even if you're a statistician, it will be difficult. Now, clustering is not straightforward. There are things like dimensionality reduction. I won't get into it now, but clustering kind of goes beyond just statistics. It involves probability theory, and to some extent, it can also involve differential calculus. Okay, don't worry about the mathematics. If you're concerned about the mathematics, I'll also tell you how to approach it. But the point of unsupervised learning is that you have data, but the data does not tell you what the classifications are. So let's take a data set for cars. You know the brand of the car, you know the model of the car, you know the weight of the car, the number of seats, you know the number of gears, you know its engine, you know the width of the wheel, the height of the wheel. Okay, but you do not know what type of car these are. What types of car are they? Are they sports car, for example, like trucks? Every big wheels. They're both wide and tall to hold on to the weight. Whereas sports cars, especially like the F1 cars, their tires are quite smooth, so they won't have no friction. They wear out more quickly, but because they have no friction, you can drive more quickly. So you have all of these information, you have all of the data, but you don't know what type of car are they. Sports car, I don't know, military vehicle, truck, what are they? And you want to be able to cluster them. You want to be able to separate them into clusters of classes. This is what unsupervised learning can do. You don't have the label, you're not told what they are, but the model can learn, oh, if the tires are smooth and the car is quite short, you know, aerodynamics, it's probably a sports car. Whereas if the car is huge, it has like 6 seats, 8 seats, and it has these massive wheels, it's probably a truck or a bus or something like that. That's what unsupervised learning can do, okay? And you can decide how many clusters there are to find, or you can just leave it to the model to find the number of potential clusters. So for example, COVID, different types of COVID variants, this will be super helpful, right? Because you would have to deal with them differently. Here's another example. If the model is able to cluster cars, it may know how fast to hit the brakes, okay, and how to, for example, if it's a big car at the red light, when the light turns green, it might take a little longer for the car to move, okay. So it will create a greater distance, and it will be more patient if it's a big car. If it's able to tell an SUV from a police car, for example. If it's a police car, you especially want to create a big distance, okay. Last thing you want is for the robot to get a ticket. And since there's no driver, someone has to get a ticket, right? So it will be you. And even besides tickets, you'll have to wait, right? Because they'll bring you on the side and you get late for your meeting. So I hope you get my idea. You hope you get the idea. Moreover, it should be able to tell that all of these are cars. Everything in here is a car. This is not a car. It should be able to distinguish what is a car, not a car. Okay? So that's an application of unsupervised learning. However, let me point out that autonomous vehicles actually use multiple machine learning techniques: unsupervised, reinforcement, and even deep learning. So this is not quite simple thing to do. Yeah, here's an example. Let's say you have this data, you have your scatter plot. Okay, now if we look at this very simple picture, if I were to ask you how many clusters are there, you would say 2 or 3, right? There's one, and you can argue that this is another one. But if you want, you can say this is 1, this is 2, this is 3. So the idea of clustering is for the machine model, for the model to identify how many clusters there are.
You have to specify the number of clusters.
In the K means clustering. K means clustering is one way of clustering. The K stands for a number. K can be 3, K can be 5. You choose the K. How many clusters do you want to find? You want 10 clusters? Your K is 10. So the model will attempt to find 10 clusters. Okay. Now there are others. For example, there is Gaussian. There's the Gaussian model for clustering. This one is a little more granular. You can have some overlap, so it's more precise. But the idea is still the same. You have a scatter plot, and you want to find out how many groups do you have. For example, let's say you're in sales and you want to segment your customers. Okay, you want to know what is it that makes these people buy your product more. So let's say this scatter plot represents your customers. Now you're a company, you're a brand that has customers from a variety of backgrounds. They can be high income, but they can also be extremely low income. Yet somehow both of them are in the same cluster. What could be the cause? Let's imagine a scenario. High-end shoes. High-end shoes. There are two people who are likely to buy high-end shoes. People who have a lot of money, disposable income, or people who are teenagers, right? Even though they don't have any money, they get their money from their parents. They're likely to spend a lot of money on shoes because they're in that age group. They like to show off. Whereas people older than that are less likely to buy your particular product.
iPhone sits very well in this cluster.
Exactly. iPhone is another example, right? iPhone, exactly. So people who have disposable income will buy iPad because they can afford it. Whereas also teenagers or college age students are also likely to spend.
Neighbors actually just go for installment to have an iPhone, like people
Exactly.
in status.
Or PlayStation 5,
Yeah.
right, Malik? PlayStation 5. If you're someone who is you could be someone who's working age, but you've inherited a lot of money from your dad. So you sit at home all day, parties, playing PlayStation 5. But even the same can be true for people who are young. They don't have any job, and since they don't have any jobs, they sit at home playing PS5 all day. My point is, you want to segment your customers. What is it that brings these two together, and then you can aim to go for the target segment that is most likely to buy your product. Okay, so for example, you can say, hey, buy this product. After work, you can let go of some stress, or you can tell kids, oh, look at these. You figure it out. You know what I'm saying. I'm not a salesperson, but I hope you get my idea.
You're doing well, don't worry.
Okay. All right. Reinforceable learning has many applications. Again, here you want to train the model to make correct decisions. There's actually an example of a autonomous helicopter, a helicopter that flies itself because it's been trained to, tilt the tail, or I really don't know how to fly a helicopter, but it has learned the parameters to fly. Other examples of reinforceable learning are trading algorithms, buying and selling stocks. There are two types of.
Useful?
Hmm?
Is it useful? Oh,
It's actually being used. It's being used. There are two types of ways you can buy stocks. Either on the trading floor, you've seen it, like on a Nasdaq, and they're all yelling at the top of the lungs. Trading floor. And what they're basically doing is they're buying and selling stocks, these people. Okay? But there are types of stocks that are being bought in seconds, faster than you can even blink your eye. Right? They're being bought and sold automatically, instantaneously, and a lot of money is being made. Because if you sell at the right time and the right amount, it can make a huge difference. Selling 5 seconds later can make a huge difference. So you can train a model to identify. You can use reinforcement learning to train a model to find what's a good stock, what's a good time to buy it, what's the good time to let it go. If you let it go when the others are letting it go, well, you're not going to be able to sell it high enough. But if you sell it just when the news breaks, so for example, Elon Musk was on Joe Rogan and he was smoking a joint, caused the stock price of Tesla to plummet. Or that time when Cristiano Ronaldo was their press conference, he took the bottles of Coca-Cola and he said, what did he say in Portuguese? No Coca-Cola.
Use water.
Yeah.
Water.
Yeah, he said, no Coca-Cola water. What happened? Google's Coca-Cola stocks took a jump, it plummeted. It fell down. Just like
Coca-Cola came later, by the way, to deny this story. It launched actually before this move.
well,
And it wasn't really.
Ronaldo's antic certainly didn't help.
What's that?
Ronaldo's antic didn't help. Okay, or there was that situation with what was that? The GameStop, right? So yeah, you can teach a reinforceable learning model to make these decisions instantaneously. Okay.
But it's more got to do with emotion than anything
Still,
else. So
what you
why
could
you
do,
would
what you
do
could
that?
do, what you could do, right? You can. How do people determine if a stock is a good time is going to plummet? If you go on Twitter, okay, if people start complaining, saying, "Oh my goodness, I never knew Elon Musk was this kind of person. I hate him," something's going to happen, because you can tell if you go by people's emotions. You know what? If you're a financial, if you're watching the stocks, you're always wary of the news. Okay.
Sentiment analysis.
Sentiment analysis, right? The sentiment analysis. If it's a negative trend, it's a negative sentiment. You can track this by the second. If it's a negative trend. If it's starting to pick up, if it's starting to snowball, maybe you want to start selling before others do. What you can do is you can also see if 2 or 3 or 4 big investors are selling, you want to sell, because if you sell a second later, you're not going to be able to make as much money. Okay, you're not going to be able to, what's the terminology? Short. Is it short or is it long?
Short.
Shorting, yeah.
If you're buying, selling short, you're buying long.
Yeah, exactly.
So it needs someone expert in the field, so he can teach.
Very good point. Very good point. So our friend here says, so you have to be someone who knows how financial markets work. Exactly. In fact, this applies to all applications of machine learning. Remember this one? Domain knowledge. You have to know. If you want to make autonomous cars, you have to know how should you brake, how should you accelerate, how should you turn.
What is the right decision in this situation?
Exactly. Or if I give you the example of dermatology, you need to know what's a cancerous tumor, what's not. Is it the color? Is it the shape? Is it the size? Or diabetes? You have to be a physician. You have to, be a biologist.
But sometimes it depends. Like it's not every time the same situation. Like maybe on autonomous cars, maybe some trucks come to my side, so will I have to go to brake or to go left or?
Well, that's you can train. You can train. So if you're someone who understands traffic systems or preventing accidents, you can train it to handle these different. You can have cameras at different angles from the back and the front. You can deal with it. Or if, again, sales, you need to know what's an important market segment. Okay. Not everyone is a potential customer. Babies are not customers. Their parents are. Well, you need to know. But you also need to know what types of markets should you even pay attention to. Okay. Certain markets are better for some products than others. For a construction company, if you want to build, if you want to get into construction, UAE, or I'll tell you that Georgia, right? Because now they're trying to invest in their infrastructure. Georgia would be a good place. So you need to know. If you're a civil engineer and you want to use machine learning, you need to know. You need someone who's in the business. And on that point, I also want to say this. Many people also have this concern. Say, hey, I want to get into data science, but I have no technical expertise. How am I? Who's going to work with me? Who's going to hire me? And I say, look, you have the domain knowledge. If you're someone who's been in the industry for 5 years, 10 years, 15 years, 20 years, 20 years worth of information, who's going to know how to use data? You, who has been in the industry for all this time, or someone who has just gone to college? Obviously, you pair your existing knowledge with some statistics and computer programming. Again, when we say data scientist, we're not asking you to be a mathematician. Just enough statistics and probability theory to understand the right machine learning metrics. Just enough. We do this in our bootcamp. In 2 months, we teach them enough to make use of the domain knowledge. So someone who has domain knowledge is much more valuable. Someone who has more domain knowledge but not enough technical knowledge is more valuable than someone who has a lot of technical expertise but that doesn't know how to use their techniques. Okay? And not to mention, there's very short supply of data scientists. There's a very short supply of data scientists. So let me skip ahead. Okay, now of course I'll share these slides with all of you. We have 3 more minutes, so like I promised, I want to answer any questions that you have. So let me also quickly map this. You can ask while I do this. So we said that we have machine learning. If you have any questions about what we covered, we have 3 types. What was the first type? Supervised learning. Unsupervised. And it's called unsupervised, by the way, because the model does not need to be supervised to find the clusters. It will do it itself. It will figure out that this cluster of things have this in common, this cluster of things have that in common, that cluster of things have that in common.
How can I validate?
Excellent question. How can we validate the performance of a model? So machine learning, right? So let's call these types of machine learning. And let's make this machine learning. So these are the types, right? Now, machine learning have characteristics we call metrics. In statistics, when you do regression, when you do classification, you can measure the precision of your model. We also have that, since machine learning is just statistical learning, we have something called metrics. So if you're doing regression, there are different ways you can measure the performance of the model. They're basically numbers. If it's below this number, it's a good, if it's a bad, if it's a bad. So for example, you have something called mean squared absolute error. If the error rate is small, it's a good model. In classification, we have something called precision recall. Exactly. If the precision recall is close to 1, that's a good model for classification. Same thing with unsupervised, and there are other ways you can measure. So for example, in fact, when you do regression, you have to actually take both of these into account. Okay, but again, this is more statistics. Okay. Now, sorry to interrupt you. You don't need to know exactly how these are solved, just so you know how to interpret the numbers. Is 0 a good number or is 1 a good number? How high or low should the number be? So you don't have to solve this by hand. Just know what they mean, what they stand for, and how to interpret them. Yes?
My question is, for regression and classification, I know the result, Y value, if it's correct or not. But in unsupervised models, what if my clustering algorithm does not, let's say, do well? How can I say, no, it's incorrect? It's not accurate.
Again, we have metrics for that.
I don't know. Either me also, I don't know if it's correct or not, right? The clustering.
Yes.
Yeah.
Well, it depends. It depends if you're going with k-means clustering, but then the thing is, leading up to PCA, leading up to clustering, there are some techniques you need to do, like PCA, dimensionality reduction. If you're able to find something called the principal components, that is one way for you to see if this model is able to actually determine different clusters of data.
PCA,
Principal component analysis. This comes from linear algebra, which allows you to do something called dimensionality reduction. Okay. So we have metrics. Now the mathematics of machine learning. I've said this before. Let me bring this up here. There are plenty of tutorials on machine learning, but they're all almost exclusively about Python programming. They do not get into the mathematics. If you avoid the mathematics, you're not going to get very far. So like I said, machine learning is really a mathematical discipline. And I think I messed this up. Anyway, I have it from the other slides. I have it from the previous slides here. And if you remember, I said that you want to learn these topics left to right, top to bottom, getting more advanced as you make your way to the right. So you can learn. I said for someone who wants to learn this, you need to learn Python. There are these things we call the 6 programming constructs. Again, you can watch the recording from episode 1 to see what those 6 programming constructs are. But then you need to learn statistics. And there are 2 levels. There is descriptive statistics. So if you never learned this before, a good starting point is descriptive statistics. Understanding frequency charts, scatter plots, basically visualizing data. Then the next level is to get into inferential statistics, making inferences, gaining insight from data. To do this, you need to learn probability theory. Statistics, inferential statistics depends on probability theory. But not probability theory alone. To continue making advances, you will encounter calculus very soon. If you want to work with a normal distribution, this is the most universal distribution of data. You will encounter calculus. And then if you're going to be calculating multiple samples of data, you will encounter linear algebra. So and once you get to machine learning, you will have things like deep learning, which involves the gradient descent. So that's differential equations. But yeah, I would say map these down. Now, also let me say this: every time I say this, people sit back and say, "What is this?" And my answer is this: the biggest barriers to learning math is 2 barriers. One of them is the notation. I said this before. If you're not able to tell the meaning of characters, you're not going to get far. The number 2 is the terms. Like you need to tune your ear, let's say, to hear when you hear a word to know what it is. Okay. For example, when you hear the word statistic, what is a statistic and what is a population? What's a parameter? What's a coefficient? If you now we're running out of time. I can't start a new workshop, but this is what we do in the boot camp, in the data science boot camp. Rather than teaching them, making it turn into a mathematics boot camp, we teach them the vocabulary, the symbols of mathematics. When they learn the symbols, they can make sense. They can read on their own, and they can take it to the next step. Again, if you want, you can watch the previous episode for those who weren't here, and you can learn about that.
Will you be able to share a link for this session, please?
Yes, and also I also had a 1-hour workshop some time ago on statistics and probability theory, just on the notation. So you can also find that on the YouTube channel. That hopefully will be useful. Anyway, if anyone has any questions after today's session, that's my email. You can reach out to me, and I'll be happy to help you. But that's it for today, everyone. Thank you for joining me. I look forward to seeing you in episode 3. Until then, enjoy your evening, and bye-bye.
When is the next episode?
It should be Tuesday.
Coming Tuesday.
Coming Tuesday, yes.